Thank you for the introduction. And my name is Wei. And today my topic is bulky binary unified layout for key-value interchange. So nowadays, every day, everyone is talking about big data. So oftentimes to manage well big data, you need to manage small data really well. And for a lot of cases, you've seen we have parallel file systems, we have databases, we have data stores, data warehouses, and also we have applications. And we have tons of various of heterogeneous data flowing in between these different layers and different, let's say, data stores or file systems, and even the applications. And oftentimes, we have particular small data that are heterogeneous and loosely coupled, and those are either metadata or labeled data. And sometimes they can exchange or transform into each other. So we have, for example, for metadata or data querying scenario, we can, for example, taking an example for the Open Catalyst 22 dataset. For example, we have data objects that have many different fields, and also we have the queries that are asking for different set of fields. And also, oftentimes, the metadata is no longer actually in the form of a that can be represented by text. So oftentimes, right now, with the prevalent use of the large language model and RG techniques, oftentimes metadata is actually stored in vectors. And also in some machine learning training applications, we have seen that, for example, for even one sample, we have multiple heterogeneous ND arrays that need to be stored all together. And if we have that multiple ND arrays, I mean, each time you need to load a single ND array that becomes a single request. However, what if you want to simply load this single sample just in one request? You need a certain format to help you to organize multiple ND arrays all together. So in terms of this, we need to have a format that is schema-free to allow you to freely organize your data in any format. And also, we need to make sure that it is compact so that we can reduce the data transfer bandwidth. And also, has to be binary because oftentimes we're not only representing like textual format. And also, it should be parsable, which means it should be machine readable. And we don't want a dedicated procedure to parse the heterogeneous data. It should be self-aware. And from another perspective, key-value format is actually really foundational. Oftentimes we can see, like, for example, different data formats like tabular format, Parquet, or graph, or like JSON. However, for all of these data formats, they can be essentially translated into key-value formats. And also, among all the available or existing data formats, we have noticed either they are, for example, schema-free and parsable like JSON, but it is not compact enough. Or they are schema-free or and compact, but it is not really parsable like message pack. Or it is compact, parsable, but really not schema-free. For example, like protobuf, Avro, or Apache Arrow. You need to define the schema files, and that stop you from like changing your format from time to time. So that's why we come up with this bulky binary unified layout for key-value interchange. So it is schema-free, which allows you to organize your data in a flexible way, and also it is compact, so it can make your data really transfer ready. And also it follows a key-value structure that is really parsable. The smallest unit in bulky is the bulky entity. So it can represent the any scalar value or an array of primitive types or another bulky entity or another bulky. So bulky is basically a key-value structure with the key and value to be the bulky entities. So the best part of bulky is that when you have your data stored in memory in the BULKI format, you can basically do this on-demand data serialization. You can basically identify which part of the data is needs to be transferred to another site. So you can basically, like this picture shows, you can consider it to be like a really big chunk of ice. And whenever you need any part of the ice, you can just basically chop it off and melt it and transfer it to whatever it needs to be transferred to. We provide different APIs for example, creating the BULKI structure. For example, you can see we can have this key and value to be the BULKI entities, and you can insert different kind of data, either the primitive data or the ND array into the key and also the value. So the key no longer is like a single value, but basically you can combine a series of data into the BULKI entity. And also we provide API for you to be able to manipulate your data. For example, you can basically insert another ND array into the BULKI entity, which serves as the key. And also we provide some other APIs for you to do, for example, data retrieval through the index approach, or maybe by iterating every key. Also, we provide you the iterator to go through every element or every BULKI entities. And also, we provide APIs for serialization and deserialization, and also utilities for you to calculate the size and for you to evaluate whether two BULKI entities are equal or not. We can also do definitely release memory when you need to destruct the BULKI structure. So we did some evaluation. For example, on the left side, we have this data-intensive comparison where we have different number of objects created, where for each object we create five attributes. And for serializing this, finally, as you can see, as compared to Avro and protobuf, which is the format that requires a schema. Our format, BULKI, is only a little bit larger than Avro and protobuf. But for those schema-free formats, for example, like message pack and JSON, our format is way more smaller than the schema-free format. And when it comes to the metadata-intensive scenario, for example, on the right side, as you can see, as we increase the number of attributes for a single object, as you can see, BULKI beats all the formats we have tested. And also in terms of serialization speed and deserialization speed, as you can see, the throughput for serialization operations, BULKI beats every format we have tested for both serialization and deserialization. In conclusion, BULKI is a dynamic structure that allows you to combine any heterogeneous data in any form. And also it provides you the ability to serialize and deserialize your data and transfer that to whatever the place that you want. And also it provides the self-guided data parsing mechanism for you to go through the structure. So for future work, definitely would like to expand the capability for multilingual support. Like, for example, we need to support Python or Rust or Java or some other programming languages. Currently, it's totally in C. And also, we would like to provide some, for example, security features like, for example, encryption. And also, we'd like to provide some features like, for example, compression on the data part. Yeah, so that's pretty much. And if you are interested, please scan the QR code and talk to me. And yeah, that's everything.